Hello. Last time we talked about Lorentz transformation, which pretty much tells us how positions and time differ between different observers. By different observers, we mean if they're moving with respect to each other. Today, we want to specifically talk about how measurement of length differs between different observers who are relatively moving with respect to each other. This is broadly called length contraction, length contraction. And as the name suggests, it means that if the observer is moving with respect to a certain length being measured, then he or she will measure it to be contracted with respect to the observer who would measure it when he or she is at rest with respect to the rod. So let's have a rod. Uh, let's have a rod. And let's, with respect to a particular frame, the left end of the rod will be Z1 measured at time T1. So every event, the event of measuring the left end of the rod is an event. So that's Z1, position is Z1, and it was measured at time T1. Similarly, you go to the next end of the rod, that's Z2, measure the position, that's Z2, and the time is T2. That's the two events that's needed to measure the length of the rod. The length of the rod itself will be defined to be delta Z by this observer, and that is Z2 minus Z1. So this will be the length of the rod. We have not really specified as of whether this observer is moving with respect to the rod or not. That comes, that will be specified in the measurement of time. So measurement of time involves delta t, which is T2 minus T1. This could be anything. It could be zero, it could be non-zero. It depends on when, uh, at what times the two measurements were made. But here is what the method of measurement of a measurement involves. We will require this to be zero if the observer or the frame is moving with respect to the rod. And no condition, so this is not equal to zero, or it could be zero also, or zero if it is at rest. The observer is at rest with respect to the rod. That's the prescription for measuring length of a rod. Again, if you're in a moving frame, that means to say the rod is moving with respect to you being the observer, then it is necessary to come up with a technique such that the two measurements, the left end of the rod and the position of the right end of the rod, have to be measured at the same time. With this methodology in our mind, let's pretend that we have two such observers. One is at rest, one is moving, and we know using Lorentz transformation that these measurements are related by the Lorentz transformations. That's equal to gamma, beta gamma, beta gamma, and gamma. delta z and c times delta t. Right. Here, beta is the relative velocity. I should point out beta is v over c, v being the relative speed between the two observers, and gamma is equal to 1 over square root of 1 minus beta square. Let's now we have to specify which observer is moving and which one is stationary. Delta C, we say is the moving observer, or let me say length measured. So length measured by moving observer. Since this observer is moving, it is necessary, as per our prescription of measuring the length of the rod, that this has to be equal to 0. Delta t here, since here she is moving, has to be 0. They have to come up with a technique that involves measuring this length simultaneously. That means measuring the two ends of the rod simultaneously. So that delta t has to be equal to 0. Delta z prime here is the length measured by in the rest frame by a stationary observer. By stationary observer, we mean the observer is stationary with respect to the rod. And there is no condition at all put on delta t prime, because he or she is at rest. So you can bring a ruler, keep it close to the rod and move around, take your own time to go from one end to the other, and that's perfectly okay. With this, it is very clear. It's immediate to write down the relation. Delta z prime is equal to gamma times delta z. So remember, delta z is the length measured in the moving frame. So let's write it on the left-hand side. And this is z prime over gamma. And since gamma is always greater than 1, the length measured in the moving frame will be always smaller than the length measured in the stationary frames. Thus, length indeed contracts. And that's length contraction. Thank you.